Hello and welcome to Obviouscast episode 2. Today we are going to start a series I'm going to call Let's Build a Role-Playing Game, where we will use Obvious to build our very own role-playing game in the style of something like Final Fantasy or Chrono Trigger or Mass Effect. Now keep in mind that I'm not an artist, so we won't have all those cool graphics, but it will be a role-playing game and it should hopefully be fun. And today we are going to start out by describing the use cases. So, a couple things about this series. We are going to try and build this in real time. I've never done this before, so we'll see how it goes, but I'm going to actually try and just code as I talk and see what happens. So if there are mistakes, I'm sorry in advance. Um, we don't really know what the game design will be. We don't really know where we want to put it, so this is going to be a very iterative process, and it should be a lot of fun. So, a little bit about how you would build an app with Obvious, and these sort of guidelines work for all Obvious apps really, is you want to start with the use cases. You want to start with what the application needs to do, what makes it interesting, and then you build the app portion of your project. Once you have that working, you want to move on to the delivery mechanism, and once you have the delivery mechanism working in, say, the file system, you start plugging in your external things like databases and queues and email, all those things. But right now we're going to start by starting with the use cases, and let's write some code. So let's swap over to our terminal here. Hide that. So we're going to just start a new project. We'll call it Little RPG. And cd into that. Start a Git repo there. And we'll go ahead and open source all of this project at some point as we go, so you'll be able to watch as we make progress. So let's start a new branch here. Oops. It's not liking me. Well, let's ignore that for now. Actually, okay. Okay. Oops. Told you this wouldn't go smoothly. Alright. Alright, we're on the use cases branch. Alright, let's create the descriptors directory. Load up Vim. Alright, so what I usually do when I get started is I will be looking at what are the things that a program needs to do, and before I even figure out how they're going to do it, I just start making a list, and these become the actions of our project. So I just start by touching all the files that I think are going to need to exist as descriptors. So let's see, we have a role-playing game. In a role-playing game, you have a battle. So let's say that our game's basic design is you will have one hero, and a hero can do battle with one monster. We'll make it as simple as we possibly can. So we have a hero, we have a monster, they can have battles. So what kind of actions would you have there? Well, you'd start a battle. What else? You might want to attack the monster. You might want to defend yourself. So that would be like putting up your shield, I guess, or trying to dodge an attack, maybe. You might cast a spell. See, other things that would happen in the context of a game. So when you attack or defend or you cast a spell, those things are going to have various outcomes, such as your health going up or down, the monster's health going up or down. It's going to send you back information about a battle that's going on. You would have a... Ooh, you might try and run away from a battle. Let's see what else. You would need to... let's see. In any of these cases, you could potentially end a battle, but the end battle would happen... We'll say finish battle is another action that our program could potentially call when the victory or defeat has happened. That makes sense, I think. And then the finish battle action might do something like end the battle. You might be able to collect loot from that, or you might gain experience from that, and those things will just happen as part of the finish battle action for now. So that would be a simple battle. Other things you might want to do, you might want to view your inventory. You might want to be able to view your stats. I guess for now this would be just a battle game, so we're not going to need to have much story or talk to anyone. It'll just be battle, battle, battle. I think that's probably a good start. So now that we have these files of descriptors, let's go in here and let's start looking at a descriptor. So let's pull up an example descriptor from the Obviouscast project so you get an idea of what a descriptor looks like. So a descriptor is a sort of shortcut tool that we use to describe at a really high level what our actions and things should look like. So we'll just copy paste one. And this is obviously not even close to correct. So let's rename it. I'll call it attack monster. So what does the attack monster do? Well, attack monster is going to the hero is going to attack the monster in the context of a battle. So there's not really much input. What would really be happening here is you would want to get the battle data. So we'd want to get the battle data. We would want to create our, or populate, create a new hero and monster entity from the battle data. We would then, so if the hero attacks a monster, you would calculate hero attack. Actually, we would want to calculate the attack order based on the hero speed and the monster speed. Since we are creating a new hero and monster entity, those are actually going to require a hero.new and a monster.new. Actually, those would probably just be, yeah, we'll call them that. Calculate the attack order. We would then we would calculate the damage, and then we would update the battle data. Probably also going to need battle.new. So we would update the battle data. We will then save everything to save battle to Jack. So what I'm thinking is that the battle is going to contain the current state of a hero and a monster in battle, but we wouldn't update the hero and the monster status in, say, a database or a third-party system. That current state of a battle would just live on that battle data structure. And then that will require battlejack.save, probably battle to hash, save the stash, okay, and then we will return the battle data. Okay, so this is an action where you are going to be attacking a monster, and so we'll say in a battle you can attack a monster, you can cast a spell, you can defend yourself, and that will all change the battle status. So that is attacking a monster. We will use that as a template for casting a spell. Okay, so we would need to once again get the battle data. Oop, we made a mistake. We're going to need to actually require battlejack.get. Okay, so back to work. So we get the battle data, fixing attack monster. Okay, so back to casting a spell. So we would need to get the battle data. We would again create a new hero and monster entity, likely from the battle data. We would, in this case, we will need to get the spell data. So we'll get the spell data. We will then need to calculate the spell effects. We will still need to calculate the monster effects. So we'll assume that actually we'll make it more explicit. We will calculate the attack, we'll say action order, after we calculate the spell effects, so that actually, you know what, that should happen. Oops. The action order should be calculated before we calculate the effects. So we calculate the spell effects or the monster effects depending on order. We'd update the battle data and save it to the jack, and we would again return the battle data. So again, very sort of similar idea, but the idea is that again we're just creating these sort of shortcut high-level ideas of what the actions of our app are actually going to look like. So defending yourself, oops. So the hero defends in a battle. Get the battle data, hero and monster entity. We don't have a spell here. Calculate the action order. And really we're just calculating the monster effects based on our defense. Update the battle data, save to the jack. So we will skip finishing a battle. Actually, you know what, we'll do that one even though it's pretty different. Finish battle. So the battle ends and outcome is calculated. So in a traditional RPG you get experience points or gold or items, so this is what we will use to calculate what ends up happening at the end of a battle. So you'll get the battle data, you will create a new hero and monster entity, we will then use the hero and monster entity to determine how much experience points were gained, how much gold was gained, if any items are dropped. So what we'd really be calculating is we'd calculate something like the gold gained, calculate the experience gained, calculate the items gained. And so the reason I'm using calculate here over and over again is that we're going to have to determine the probability of these things. We are going to determine if the hero leveled up. We will need to delete the battle data. And you can almost think of a battle in our system as almost like a session, where there's some hero state, there's some monster state, and so when the battle is complete, we can sort of delete that battle session, and that would be over. So that would actually be battlejack.delete. We shouldn't need battle to hash there. And then we would return, I think there's no reason to return the battle data we could return the hero data because that's going to be the thing that changes. We're going to okay, and we're going to save the hero data. Okay, so it's here. Okay, so running away. So run away is our action. Hero. Oops. Hero attempts to run away. Again, get the battle data, create the entities. What we're going to really be calculating is calculate the escape possibility. And then we're going to calculate the monster damage if you got attacked and you weren't able to escape. And then we're going to update the battle data and save the battle data to Jack and return the battle data. So when we actually build this, we'll probably need to have some sort of battle state where you could say runaway could be set to true, and at the end of a battle, when we maybe check the battle state, we would need to actually look and say, oh, they ran away, so finish the battle. So starting the battle, we'll actually look at finishing the battle and, oh, run away. Start the battle. Okay, we'll use finish battle as our template here. Battle starts. Okay, so what we are going to do is we are going to get the hero and monster data. Again, we create a new hero and monster entity, and in this case, we are going to create a new battle entity. Based on the hero and the monster. Requires battle.new. Let's see. Nope, that's not it. And then we are going to save the battle data. And okay, we're almost done. View the inventory. So a hero is likely going to have some inventory. So viewing it would probably just send back a list of items, something like that. So let's look at something like this. So viewing the inventory should do something like return a list of items in the hero's inventory. So we'll want to validate the input. We will want to get the hero data. A side note, I'm using new here instead of populate because we will be using the new obvious entity class. So kind of a little different than the obvious status stuff, but we'll probably update that at some point. So this will return, will require, let's see, we'll return inventory list. We'll probably require something like hero probably like hero dot inventory to hash. We'll just call it hero dot inventory. In theory, that's probably what we'll need. And again, this is just sketches. We will be changing the code once we generate it. View stats is going to be almost the same, but instead of an inventory list, you'll just get the stats of our hero. So return hero data. Okay, validate the input, get the hero data from the jack, populate the object, and return the hero data. So, great. So those are really super basic actions. There's probably some that we forgot, but this is going to be a start. So once you have the descriptors written, you will go back to your home directory, our little RPG here, and we will say, well, let's go ahead and commit these. Wait for our Git GUI to pop up. Alright, so we'll just add all these. Created descriptors. Commit. Alright, let's close that. Alright, now if we go back to our code here and hit refresh, we now have an app directory where all of our actions have been created. And you notice that you have all of these comments right here in the code, and those come right from these code comments here and our descriptors. It already links up our entities that we'll need, and it already sort of has the things in place for the jacks. So let's go ahead and let's run the test first. Oops. All right, we need to be in the app directory. Actually, no, we don't. Can run the rake file that is generated for you, and something went horribly wrong. Module name must be constant. So it looks like we have a bug somewhere, but we will go ahead and add monster one, attack monster. Oh, are we not requiring obvious somewhere? Maybe. Well, it shouldn't need anything. Nope, that's working. Class module name hero must be. Oh. Entities hero. Oh. Oops. That was our fault somewhere. Oh boy, I'm not escaping things. Great, we are running into all kinds of issues. So let's fix that real quick too. Told you this would be real time. View inventory spec. Spec. Maybe? Nope, we're still got errors. Great, what else? Hero spec. So this is what happens when you put the wrong requires somewhere, as I must have. Okay, great. So we have 47 example specs. We have some that are pending, and so that's what we're going to be building out in the next episode. I apologize for a couple mistakes, but that is bound to happen as we are coding this live. So, I hope you enjoyed the second episode of Obviouscast and the first in our series of Let's Build a Role-Playing Game. And I hope you tune in next time for our next fantastic episode.